Hello guys, in this video we are given a cubic function question which is part of calculus. The question reads, the graph of g of x is equal to ax cubed plus bx squared plus cx plus d is sketched below. The graph of g intersects the x-axis at x is equal to -2 and touches the x-axis at x is equal to -3. K is a turning point of g. The graph g casts the y-axis at 0, 9. Okay, so that's our graph. Then 8.1, show that a is equal to half, b is equal to -2, c is equal to -3/2, and d is equal to 9. Okay, so in this case we are given the roots of our graph, which is -2 and 3. The roots are the x-intercepts, but this one, it is turning at the x-intercept, so it means this graph has repeated roots. So it is using the x-axis as the turning point as well as the x-intercept. So the roots of this equation, of this graph, is going to be x is equal to -2 and x is equal to 3, or x is equal to 3 again. This is a cubic function. It has 3 roots. But if the graph is like this, turning on the x-axis, it means it has a repeated root. So we're going to write our general form in the factorized notation, which is like this. G of x is equal to a open bracket x minus x1. x1 is the first root, then x minus x2, then x minus x3. So our g of x will be equal to a open bracket x minus x1. Our x1 is -2, so that is going to be x minus -2, then x minus x2. x2 is that 3, so I'm going to say x minus 3, then x minus 3 again. So this is going to be g of x is equal to a open bracket x plus 2, x minus 3, x minus 3. I can say x minus 3 squared, like that. Then now we want to find the value of a. To determine the value of a, we find any point which is lying in the graph, which is not the x-intercept. So we're going to use our y-intercept, this one, 0 and 9. So we're going to substitute with 0 and 9 in order to help us to find the value of a. So this is going to be 9 is equal to a, open bracket, our x is 0. 0 plus 2, 0 minus 3, then squared. 0 plus 2 is 2, 0 minus 3 squared, which is 9. 9 times 2, which is 18a. Then this is equal to 9. So by dividing by 18 both sides, we'll get a is equal to half. After we get our half, now we come back at this stage. We substitute with the value of a. So that is going to be g of x is equal to half x plus 2, x minus 3 squared. Then that is going to be half, open bracket, x plus 2. I want to expand this bracket, so I'm going to use the direct expansion to expand this one directly. So we square the first term, which is x. So this is going to give us x squared. Then we say x times -3, we get -3x. Then times 2, we're going to get -6x. Then -3 squared, we get +9. Then let us expand these two brackets. I'll keep my half here. That's going to be x times x squared, we get x cubed. Times x times -6x, we're going to get -6x squared. X times 9, we get 9x. Then 2 times x squared, we get +2x squared. Then 2 times -6, we're going to get -12x. -2 times 9, which +2 times 9, which is 18. Then we collect like terms inside the bracket. X cubed, this is -6 x squared plus 2x squared. We're going to get -4x squared. Then 9 minus 12, that is going to be -3x, then plus 18. Then we distribute the half inside. That is going to be half x cubed. Half times -4, we get -2x squared. Half times -3, that is going to give us -3/2. Then half times 18, which is +9. So this is our g of x. So we can see now we have determined our value of a, b, and c. So we'll come back here. That's where you match your values then. So the value of a is the coefficient of x cubed, so a is equal to half. Then b is the coefficient of x squared, so coefficient of x squared is equal to -2. c is the coefficient of x, which is -3/2. Then d is the constant value, which is a null. Next one, 8.2, determine x coordinate of turning point of k. So now we know our g of x is defined as half x cubed minus 2x squared minus 3 over 2x then plus 9. So for us to determine the turning point, we're going to find the first derivative, because first derivative will give us the gradient function, but at stationary points the gradient is equal to 0. So we find the first derivative, then we equate it to 0. So on our solution we get two values of x, which is for this turning point and this one. We already know the turning point, and this one is 3. So the other answer will be the value of k. Okay, let us see how we can do it. So we find the first derivative, g prime of x, then we drop the 3. We're now differentiating this one. That is going to be 3 over 2, then x power 3, then we subtract 1, we're going to have squared. Then minus, we drop the 2, that becomes 2 times 2, which is 4x, then subtract 1 to remain x power 1, then minus, we drop a 1, it stays 3 over 2, then power 1 minus 1, that will give us x power 0, which is equal to 1. So it will stay minus 3 over 2 like that. Then we equate it to 0. Equating to 0 is because the gradient at turning point is 0. So g prime of x is equal to 0. So this means 3 over 2 x squared minus 4x minus 3 over 2 is equal to 0. Then we can multiply by 2 throughout to clear out the denominators. So we'll be left with 3x squared minus 8x minus 3 is equal to 0 like this. Then we solve for x here. There are many ways of solving this one. You can use the quadratic formula. You can use the factorization method. Also, you can use your calculator. Our first answer is minus 1/3, or x is equal to 3. So x is equal to 1/3 minus 1/3, or x is equal to 3. But 3 is this one. So the x coordinate of k is going to be minus 1 over 3. So I can call it kx. And let us go to 8.3, for which values of x is g concave up. For us to determine whether the graph is concave up or concave down, we need to find the point of inflection, because point of inflection is the central point or the midpoint between the two turning points. Let me just assume that maybe it's here. So from this point of inflection, you can see if this side our graph is concave up, this side our graph is concave down. Concave up shape is like this, U shaped. Then let me say concave up. Then concave down is like this. So the point of inflection is the reference point where you say, okay, from here to the concave down, then from here to the going to the right is concave up. So we need to find the point of inflection. To find the point of inflection, we need to find the second derivative for this function. We've already done the first derivative, so we just take it further from the first derivative. So now our second derivative, we drop the 2. It is going to be 3 over 2 times 2, which is 3. Then x power 2 minus 1, we get 1 like that. Then minus the 4. Then at point of inflection, our second derivative is equal to 0. So g prime prime of x is equal to 0. Then so we equate 3x minus 4 to 0. So our x will be equal to, we take 4, then we divide by 3. That will be equal to 4 over 3. So our graph is concave up from 4 over 3 going to the right. So mathematically we can say x is greater than 4 over 3 when the graph is concave up. So our solution say therefore x is greater than 4 over 3. Some can use the other notation to represent this one. Since we are from 4 over 3 up to this side, we don't know where we end. So we're going to positive infinity. So we can say x is an element of 4 over 3 up to positive infinity. 8.4. Determine the coordinates of P if the gradient of tangent to the graph P is equal to minus 7 over 2. P touches G where G is concave up. So in this case we are given the gradient. And all we know is that the first derivative of any function is the gradient function. Then we find our first derivative, g prime of x. This is going to be equal to 3 over 2 x squared minus 4x minus 3 over 2. So in this case, we equate it to our gradient, which is minus 7 over 2. Then we can clear out the denominators, this denominator 2, by multiplying by 2 throughout. So this will give us 3x squared minus 8x minus 3 over 2 times 2, we get a 3 like that. Then is equal to minus 7, because if we multiply by 2 again, and 2 and 2 cancel, leaving minus 7. Then we take 7 to the left, so that we can solve the quadratic equation. So this will be 3x squared minus 8x, then minus 3 plus 7, that is going to be plus 4, is equal to 0. Then we can solve the quadratic equation. We can use quadratic formula, or we can use the calculator. So I'm going to use the calculator to solve this equation. So this is going to give us x is equal to 2 over 3, or x is equal to 2. But as we can see, we got two values of x. But p is just one coordinate, so we need one value. So the question says p touches g where g is concave up. So g is already concave up, which is this side. So meaning the value of p must be greater than the point of inflection. That's where our graph is concave up. So which value is greater than 4 over 3 there? We can see that it's 2. So meaning 2 is going to be the x value of p. So our px is equal to 2. Now we want to find the y, because the question said determine the coordinates. So to find the coordinates, now we substitute this value into the original equation, which is this g of x. Don't make a mistake of substituting into g prime of x. That is going to give you a wrong answer. So let us substitute and see what is our py. That is going to be half 2 cubed minus 2, 2 squared minus 3 over 2 multiplied by 2, then plus 9. This gives us 8, which is 8 divided by 2, we get a 4, minus 4 times 2, which is 8. Then this one becomes minus 3, then plus 9. 4 plus 9, which is 13. 13 minus 8, we get 5. 5 minus 3, which is equal to 2. Therefore, the coordinates of p will be 2 and 2.